Welcome. Today we're diving into the world of precision measurement with the screw gauge, a tool that's essential in labs and workshops. Whether you're a student, engineer, or hobbyist, understanding how a screw gauge works can make a big difference in your projects. This video will guide you through its structure, working principle, and practical uses. Let's start by exploring what a screw gauge is and why it's so important for measuring small dimensions with high accuracy. Screw gauge, also known as a micrometer screw gauge, is a device used to measure very small lengths, thicknesses, or diameters. It's commonly used in mechanical engineering and metalworking where precision is crucial. The screw gauge can measure objects as small as a few micrometers, making it far more accurate than a standard ruler or caliper. Its design allows for fine adjustments, ensuring that even the tiniest differences in size are detected. Let's break down the main parts of a screw gauge. The frame provides the structure and support. The anvil and spindle are the surfaces between which the object is placed. The thimble and sleeve have scales for reading measurements. The ratchet ensures consistent pressure, and the locking device holds the spindle in place. Each part plays a vital role in achieving precise measurements, and understanding their functions is key to using the tool correctly. Frame of the screw gauge is typically made of strong metal to provide stability and durability. It forms the backbone of the instrument, holding all the other components in place. The frame's rigid structure ensures that measurements are not affected by bending or flexing, which is crucial for maintaining accuracy. When you hold a screw gauge, you'll notice the frame's solid feel, giving you confidence in its reliability. Anvil and spindle are the two surfaces that come into contact with the object being measured. The anvil is fixed, while the spindle moves towards or away from it as you turn the thimble. These parts must be perfectly aligned and smooth to ensure accurate readings. When measuring, the object is gently clamped between the anvil and spindle, allowing for precise measurement of thickness or diameter. Thimble and sleeve are essential for reading measurements on a screw gauge. The sleeve is marked with a linear scale, while the thimble has a rotating scale. As you turn the thimble, the spindle moves and the scales work together to provide a precise measurement. Learning to read these scales accurately is a key skill when using a screw gauge, and we'll cover that in detail soon. Ratchet mechanism is a small but crucial part of the screw gauge. It ensures that the spindle applies consistent pressure to the object being measured. By turning the ratchet, you avoid over-tightening, which could damage the object or give inaccurate readings. The ratchet clicks when the correct pressure is reached, making it easy to know when to stop turning. Locking device on a screw gauge is used to hold the spindle in place once you've taken a measurement. This feature is especially useful when you need to record or compare measurements without the risk of the spindle moving. By locking the spindle, you maintain the exact position, ensuring your readings remain accurate even if you set the gauge aside for a moment. Screw gauge operates on the principle of a screw. When you rotate the thimble, the spindle moves forward or backward depending on the direction. The distance the spindle moves with each rotation is determined by the pitch of the screw. This allows for very fine adjustments, making it possible to measure tiny differences in size with great accuracy. Pitch of the screw is the distance the spindle moves forward with one complete rotation of the thimble. For most screw gauges, the pitch is 0.5 m, meaning the spindle advances 0.5 m for each full turn. This small movement per rotation is what allows the screw gauge to measure with such high precision. Least count of a screw gauge is the smallest measurement it can accurately read. It's calculated by dividing the pitch by the number of divisions on the thimble. For example, if the pitch is 0.5 m and there are 50 divisions, the least count is 0.01. This means the screw gauge can measure differences as small as 1/100th of a millimeter. To use a screw gauge, you first read the main scale on the sleeve. This scale is marked in millimeters, and you note the last visible marking before the thimble edge. This value gives you the main part of your measurement. It's important to read the scale carefully to avoid errors, especially when working with very small objects. Next, you read the thimble scale, which is marked with divisions around its edge. The division that lines up with the main scale's reference line is your thimble reading. This value is multiplied by the least count to get the additional measurement, which is then added to the main scale reading for the final result. To get the final measurement, simply add the main scale reading to the thimble scale reading. For example, if the main scale shows 5.5 m and the thimble scale shows 0.23 m, the total measurement is 5.73 m. This method ensures you capture even the smallest differences in size. Zero error occurs when the screw gauge does not read 0 when fully closed. This can be a positive or negative error, and it must be accounted for in your final measurement. Always check for 0 error before starting and adjust your readings accordingly to ensure accuracy. Positive 0 error means the reading is above 0 when closed, while a negative 0 error means it's below 0. To correct for 0 error, subtract the error value from your final measurement if it's positive or add it if it's negative. This step is crucial for maintaining the accuracy of your results. To measure an object, place it between the anvil and spindle. Turn the thimble until the object is gently clamped, using the ratchet for consistent pressure. Lock the spindle in place, then read the main and thimble scales. Don't forget to check for 0 error before recording your final measurement. One common use of the screw gauge is measuring the thickness of wires. This is especially important in electrical work where precise wire gauges are needed. By following the steps we've discussed, you can accurately determine the diameter of even the thinnest wires. Screw gauges are also used to measure the thickness of sheet metal. This is vital in manufacturing and construction where material thickness affects strength and performance. The screw gauge's precision ensures that each sheet meets the required specifications. In mechanical engineering, many components are tiny and require precise measurements. The screw gauge is perfect for checking the diameter of small rods, pins, or bolts. Its accuracy helps prevent assembly errors and ensures parts fit together perfectly. The screw gauge offers several advantages over other measuring tools. Its high precision, ease of use, and ability to measure very small objects make it indispensable in many fields. Unlike calipers, it can detect minute differences in thickness or diameter, which is essential for quality control. Despite its precision, the screw gauge has some limitations. It can only measure small objects that fit between the anvil and spindle. Large or irregularly shaped items can't be measured accurately. Also, the tool requires careful handling to avoid damage and maintain accuracy. Proper care and maintenance are essential for keeping your screw gauge accurate. Always clean the tool after use, store it in a protective case, and avoid dropping it. Regularly check for zero error and lubricate moving parts as needed. With good care, your screw gauge will provide reliable measurements for years. Some common mistakes when using a screw gauge include applying too much pressure, misreading the scales, or forgetting to check for zero error. These errors can lead to inaccurate measurements. Always use the ratchet, read the scales carefully, and double-check your results to avoid mistakes. Modern screw gauges often come in digital versions. These tools display measurements on a digital screen, making them easier to read and reducing the chance of human error. Digital screw gauges are especially useful for quick, repeated measurements in busy workshops. Both analog and digital screw gauges have their pros and cons. Analog gauges are simple, reliable, and don't require batteries. Digital gauges, on the other hand, are faster and more user-friendly but need power and can be more expensive. Choose the type that best fits your needs and budget. Screw gauges are widely used in engineering fields for quality control, research, and development. They help ensure that parts meet exact specifications, which is vital for safety and performance. From automotive to aerospace, screw gauges play a key role in modern manufacturing. In schools and universities, screw gauges are used to teach students about precision measurement and mechanical principles. They provide hands-on experience with real-world tools, helping students develop important technical skills for their future careers. In scientific research, screw gauges are used to measure samples with extreme accuracy. Whether in physics, materials science, or biology, precise measurements are crucial for experiments and data collection. The screw gauge's reliability makes it a trusted tool in labs worldwide. Quality assurance relies on precise measurements to ensure products meet standards. Screw gauges are often used in inspection processes to check the thickness or diameter of components. Their accuracy helps prevent defects and maintain high product quality. While both screw gauges and vernier calipers are used for measuring, the screw gauge is better for very small objects requiring high precision. Vernier calipers are more versatile for larger items but can't match the screw gauge's accuracy for tiny measurements. The screw gauge was invented in the 19th century and has evolved over time. Early versions were simple, but advances in engineering have made them more precise and user-friendly. Today, screw gauges are indispensable in many fields, reflecting their lasting value. Screw gauges are typically made from hardened steel or other durable metals. This ensures they remain accurate and resistant to wear, even after years of use. Some parts may be coated or treated to prevent rust and corrosion, further extending the tool's lifespan. Regular calibration is essential to maintain the accuracy of your screw gauge. Calibration involves checking the tool against a known standard and making adjustments if necessary. This process ensures that your measurements remain reliable over time. Proper storage is important for protecting your screw gauge. Always keep it in a dry, clean place, preferably in a padded case. Avoid exposing it to moisture or extreme temperatures, as these can affect its accuracy and lifespan. If your screw gauge isn't working properly, check for dirt or debris on the threads, misalignment of parts, or worn-out components. Cleaning and lubricating the tool can often solve minor issues. For persistent problems, professional servicing may be required. When using a screw gauge, always handle it with care. Avoid applying excessive force and never use it to measure objects that are too large or hard. Store the tool safely after use to prevent accidents or damage. Screw gauges are designed to be durable and long-lasting, reducing the need for frequent replacements. When disposing of old tools, recycle metal parts whenever possible. Responsible use and disposal help minimize environmental impact. Recent innovations include digital readouts, improved materials, and ergonomic designs. These advancements make screw gauges easier to use, more accurate, and more comfortable for extended use. Staying updated with new features can enhance your measurement experience. Screw gauges are available in a range of prices, from affordable basic models to advanced digital versions. Consider your needs and budget when choosing a screw gauge. Investing in a quality tool can save you time and money in the long run by providing reliable measurements. Many users find screw gauges easy to use after a bit of practice. The tactile feedback from the ratchet and the clear scales make it straightforward to get accurate readings. With regular use, you'll become more confident and efficient in taking precise measurements. If you're new to screw gauges, start by practicing on simple objects like wires or rods. Take your time to understand the scales and practice reading them accurately. Don't rush, precision comes with patience and experience. Experienced users can use screw gauges for specialized tasks, such as measuring the depth of holes or the thickness of coatings. Mastering these advanced techniques expands the range of applications and increases your value as a technician or engineer. To sum up, the screw gauge is a powerful tool for precision measurement. By understanding its parts, working principle, and correct usage, you can achieve highly accurate results. Remember to check for zero error, handle the tool with care, and practice regularly to master its use. Thank you for joining this comprehensive guide on screw gauges. With the knowledge you've gained, you're now equipped to use this essential tool with confidence. Whether for study, work, or hobby, the screw gauge will help you achieve precise measurements every time. Keep practicing and exploring new applications.